Okay, in this video we're going to be talking about algebraic expressions. How do we simplify them? What are algebraic expressions? How do we simplify them, add them, subtract them, multiply them, divide them? Basically, you can think about this as learning the rules of the road that we're going to use throughout algebra. Okay, so here we have 2x. Now, what does 2x mean? It means 2 times a number. Okay? And a number, that's x. So when we have 2 next to a number, okay, that's 2 times x. Now together we would say that this is called a term, okay? A term. But let's break down 2x. X is the variable, and 2 is what we call the coefficient. Okay, let's take a look at another term. Let's take 7x squared. So this is 7 times x squared. And what does x squared represent? X times x. So I could show this as 7 times x times x. Okay, that's what 7x squared represents. What's the coefficient of 7x squared? 7. And the variable is x squared. Okay, notice that when I broke out the x squared and I broke this down, I put a dot here to represent multiplication. I know before we were using this to represent multiplication, but that gets very confusing because now we're using x to represent unknown values, unknown numbers. Okay, so if we want to show multiplication and we're doing algebra, we're going to use dots. Okay, so the next concept we're going to talk about is like terms. So here we have 4 different terms. Now, 2 terms are like terms with each other if the variable is the same. So this term here, 7x, right, is what we would call an x term, right? We just ignore the coefficient, it becomes an x term. So if I'm looking for which of these 3 terms are like terms, I'm looking for the other x term, okay? This is not an x term. It has an x in it. This has an x in it. But this would be an x squared term. And this would be an xy term. Okay, but these here, these are both x terms. So we could combine these. 7x minus 3x. Well, when we're adding and subtracting like terms, we just pay attention to the coefficients. 7x minus 3x gives me 4x because 7 minus 3 is 4. You think about it, I had 7 candy pieces and I ate 3 of them. Now I have 4 left, right? 7x minus 3x is 4x. What could be a like term of 4x squared? Well, 10x squared, right? Just any other x squared term. So we can use this idea of like terms to help us simplify algebraic expressions. So let's take a look at one here. 8y plus 12x plus 9y squared minus 3y. Okay. So we look at this expression, and I'm calling it an expression because there's no equal sign. When we have an equal sign, it becomes an equation. So we look at this expression, and the only thing that we can do is simplify by combining like terms. So do we see any like terms here? This is a y term, x term, y squared term, and a y term. We have 2 y terms, right? 8y and negative 3y, or 8y minus 3y would give me 5y. So let's just combine our 2 like terms here. They become 5y, and then everything else stays the same. There's nothing else that I can do right now because I combined all of my like terms. Okay, so let's take a look at another algebraic expression and see if we can simplify it by combining like terms. So we need to look across all these terms and look for like terms. We're going to notice that there are 2 x terms, 7x and 8x. So I'll be able to add those 2 together. And then there are two x squared terms, 5x squared and 2x squared. Notice x squared z is not a like term with x squared. Okay, this is an x squared z term. So there's no other x squared z terms, but we have two x squared terms and two x terms. So all we're going to do is add those up. Let's actually change this to a minus. So 2x squared minus 5x squared. Well, 2 minus 5 is negative 3. So negative 3x squared. Positive 7x plus 8x, that's 15. So plus 15x. And then these other two terms, that I'll just copy them down because there was nothing I could do with them, right? There were no like terms. So plus 3y minus 7x squared z. Okay, so now we're going to talk about what happens when we multiply two terms together, right? With addition and subtraction, we just need like terms. We can only add and subtract like terms. But that's not true with multiplication. We can multiply any two terms together. Now, for this first example, these happen to be like terms, but we can multiply any two terms together. What I've shown you up here is three different ways that you might see 4x times 3x written. Okay, all of these are different ways of expressing 4x times 3x. So remember that 4x is 4 times x times, and then 3x, which is 3 times x. Okay? The order that we multiply in doesn't matter. It's called the commutative property of multiplication. So let's put the numbers next to each other. 4 times 3 times x. 4 times 3 gives me 12, and x times x gives me x squared. Okay? So I'm just breaking it out like this to show you what's happening, but we don't have to do that, right? We're multiplying two things together. Multiply the coefficients. 4 times 3 gives me 12, and then multiply the variables. X times x gives me x squared. So what if I took this 12x squared and I multiplied it by negative 3y? What would happen then? Well, let's focus first on the coefficients. 12 times negative 3 would give me negative 36. And then x squared times y is just x squared y. So negative 36, x squared y. Let's take it one step further just to make sure we're seeing what's going on here. Let's do times negative 2z. Okay. So negative 36 x squared y times negative 2z. Well, negative 36 times negative 2, that's going to be a positive 72. And then x squared y, and then I just tack on the z. X squared y z, right? Because when I break all these out and I'm multiplying them all together, it'll come out to x times y times z. These become x squared, and then we just have y z. Okay, 72 x squared y z. Okay, now we're going to talk about something called distributing. So if you look here, the 2x is being multiplied by everything inside the parentheses, right? And inside these parentheses, I can't simplify this any further because this is subtraction and these are not like terms, right? This is an x term, this is just a number. So what we're going to do here is called distributing. We're going to take basically what that means is we take the 2x and we multiply by each term inside the parentheses. So I'll do 2x times 3x and then 2x times negative 9, right? We call that distributing. So let's do 2x times 3x first. Well, that's 2 times 3 is 6. X times x, x squared. And then 2 times negative 9 is negative 18x. Okay, so 6x squared minus 18x. Again, this process is called distributing. Let's take a look at another example. Negative 3y times 2x squared minus 3y. So we're going to take this term, negative 3y, we're going to multiply it by each term inside the parentheses. negative 3y times 2x squared. Negative 3 times 2 is negative 6, and then becomes x squared y. Okay? And then negative 3y times negative 3y. Well, negative 3 times negative 3 is positive 9, so plus 9, and then y times y, y squared. Okay? Notice that because this is subtraction, I'm thinking of this as negative 3y. Okay, so what we're going to look at now is what's called multiplying two binomials. Okay, nomial is just a fancy way to say it. Name, bi, like a bicycle, means two. So when we have two terms inside parentheses, they call that a binomial. So this is a binomial, 3x plus 5, and this is a binomial, 2x minus 7. So now we're multiplying them together, right? When we have parentheses next to each other, that means we're multiplying together. So let's go over how we do this. The acronym that we can remember, but also I think you can just, if you understand the process, you don't need to remember this acronym. Okay, is FOIL, which stands for first, outside, inside, last. But basically what we're going to do is we're going to start with the first binomial and one term at a time, right? First with the 3x and then with the 5, we're going to distribute it into the 2x minus 7 just like we did before, right? So we take the 3x and we multiply it by everything that's inside the other parentheses. And then we'll do the same thing for the 5 as well. Okay? So that's what this process is going to be. When we do the first, we're going to do the first term in each binomial. So 3x times 2x. 3 times 2 is 6. X times x, x squared. Outside, 3x times negative 7. Well, 3 times negative 7 minus 21x. Okay? But let's pause for a second. We just did first and outside. But really what did we do is we just did this, right? We took the 3x and we multiplied it by both terms in the other parentheses. So now when we do inside and last, we're just repeating the process with the 5, right? Okay? So inside, 5 times 2x. Both positive, so that's plus 10x. And then positive 5 times negative 7 would be negative 35, so minus 35. Okay? First, outside, inside, last. Now, what's our last step? We just need to look to see, do I have any like terms? Yes, I do have two like terms here, negative 21x and positive 10x. So negative 21x plus 10x, that would get me negative 11x. Okay? So just like these were called binomials, a binomial, our answer here is technically called a trinomial, right? Tri meaning 3. And when we talk about things in general, these type of expressions, right? We call them polynomials. And in my opinion, the names are not so important, but I do want to make sure that I mention them. All right, so let's take a look at another example of multiplying two binomials together. We have x minus 9 times x plus 4. So we're going to follow the FOIL method. But again, that basically means we start with the x, and I'm going to distribute it, multiply it by both terms in the other parentheses. So x times x first gives me x squared. Outside, x times positive 4 is plus 4x. Inside, now I'm moving on to the negative 9. Negative 9 times x minus 9x. And then negative 9 times positive 4 is negative 36, so minus 36. From here, we just need to look, do I have any like terms? Yes, 4x minus 9x. 4 minus 9 is negative 5, so x squared minus 5x minus 36. Let's do one more using the FOIL method just to practice. So we have 4a to the third minus 3x times a squared minus 6. Okay, I know that the terms and the variables are a little funkier, but the process doesn't change. First, 4a to the third times a squared. Well, let's just review to make sure we understand what's happening here, what our answer is going to be. So 4a to the third is 4 times a times a times a times, right, here's 4a to the third, times a squared. So times a times a. Well, now how many times am I multiplying a by itself? 5 times, right? So a to the third times a to the second is a to the fifth. So if we need to be, right, we add our exponents together here. So a to the third times a to the second would give me a to the fifth. So this is 4a to the fifth. Okay, that was first. Let's do outside. 4a to the third times negative 6. 4 times negative 6, that's minus 24. And then we still have the a to the third. Inside, negative 3x times a squared minus 3 a squared x. Or we could write minus 3xa squared. Doesn't matter, but usually you'll see whichever variable has the higher power written first. Okay, so we're going to write minus 3a squared x. And then last, negative 3x times negative 6. Well, negative 3 times negative 6, that's a positive 18 plus 18x. Okay, what's our last thing we should look for? Do we have any like terms to combine? No, right? So in this case, we're done. Okay, so last thing we need to talk about is division involving Okay, so last operation we need to take a look at is division. So here we have 12x divided by 3. Remember, just like with multiplication, we don't need to have like terms for me to multiply or divide them. So here, similarly, just like multiplication, let's just pay attention to the coefficients. What's 12 divided by 3? 12 divided by 3 is 4. And because I didn't divide the x by anything, right, we just say, so 12x divided by 3 is 4x. I sometimes think it's easier to visualize these as fractions, right? Because then I'm just simplifying. Well, hey, 4 over 1, so this is 4x. The other thing that we should talk about is that same pattern we were noticing with exponents, right? We talked about x to the third times x squared is x to the fifth. Well, by that same logic then, x to the fifth divided by x squared gives me x to the third. And x to the third divided by x would give me x squared. And x squared divided by x would give me x. And if we actually keep going, x divided by x finally would give me 1. Okay? This is a little bit of a throwback, but I could keep going. 1 divided by x gives me 1 over x, or x to the negative first power. This is also x to the 0. Okay? But now I'm getting a little bit off topic, but this is important for us to keep in mind because soon, what if I was given something like this? 15x squared over 3x. Well, we're just going to cancel out, right, like we would with fractions, whatever we can here. So we could think about, again, the 15. I'm kind of showing this out a little more than I need to. This is 3 times 5 times x, and 3x is 3 times x. So notice we have a 3 that we can cancel out and x's that we can cancel out, leaving us a 1 here. So all we're left with is 5x, right? But what the process would really look like, I'd say, oh, hey, 15 and 3, that's a 5 and a 1, and then the x squared just becomes x. So we're left with 5x. Okay, so this is the last problem that we're going to look at. And we will return to a situation like this later on when we talk about something called factoring. But for now, we're not going to do that. So here we have a trinomial, okay, being divided by 6x to the third. And one option that we have if we're trying to simplify something like this is because this whole thing is getting divided by 6x to the third, I can actually break it apart. So I can break this into 42x squared y over 6x to the third plus 18xy squared over 6x to the third minus 36x to the fourth over 6x to the third. Okay? And this can be helpful because now I just need to look at each fraction and see if I have anything that I can cancel out, right? Or can I reduce this fraction, simplify it down? So I know it's a lot of writing, but to be as clear as possible, I'm going to go ahead and expand out all these exponents. So we have 42 times x times y over 6 times x times x plus 18 times x times y over 6 times x times x minus 36 over 6 times x times x times x times x times x times x times x. Okay, so now let's just take this one fraction at a time. So 42 and 6, right? Does 6 go into 42? It does, 7 times. So this becomes a 7, this becomes a 1. And then I see an x times x times x. So we can divide those by each other or cancel them out. Okay, so what are we left with in the numerator here? 7y. And what about in the denominator? X. Okay, plus, let's move on to the next one. Well, 18 divided by 6, that's 3. So this becomes a 3, this becomes a 1. I see an x that I can cancel out, but that's it. So what are we left with here in the numerator? 3 times y, or 3y squared over x times x, which is x squared. Okay, minus 36 divided by 6. That becomes a 6, that becomes a 1. And then I see x to the third. So I cancel all these out. So here we're left with 6x. And because there's only a 1 left here down in the denominator, I don't need to write it if I want to, right? I could write 6x over 1, but I can just write 6x. That's the same thing. Okay, so this was just an introduction to algebraic expressions and working with polynomials, right? We're gonna dig much deeper into this, and like I said, we could also solve this problem a different way by doing something called factoring, but we're gonna save that for a later video. So I hope that this was helpful. I hope that this has you feeling confident moving into algebra. And as always, thank you for watching, and I'll catch you in the next one.